Okay, I hope it should be working. Let me check. Okay, we should be good. So I'm gonna not try and waffle as much in the intro now. But yeah, so we're gonna do some more GCSE revision for paper two. This is predominantly for higher, but obviously the first few questions will be for foundation as well because the start of the higher paper is also the end of the foundation. So this will be benefit to everyone really, but the focus is higher. And yeah, so what I've done is I've compiled some questions on the topics that are most likely coming up. Um, the questions that I spot that seem to come up every single time, every year on the calculated paper, and also then I cross-referenced with what was on paper one. So it's unlikely the paper one stuff will come up on, you know what I mean? Apart from some key topics like ratios and stuff. So yeah, that's what I've done. So these will be a good revision resource. Going over these sort of questions. But yeah, I'm gonna just get started, I guess. To make sure we have enough time. So yeah. So question one. Um, it is an index law question. So we have n to the 3 times n to the 4, where you should know that this power law here, a to the m times a to the n. If you're times in the same number by different powers, you add them. So you have a m plus n. So in this case, n to the 3 plus n times, that's going to be n to the 3 times n to the 4. That is n to the 3 add 4, which will be n to the 7. Cool. Part B is simplify this whole bracket raised to the power 3. Again, again, if you have a to the m and fn in the brackets raised to the power n, you times the powers, right? So a to the m times n. So in this case, we have 5np cubed, which is all raised to the power 3. So by this logic, by this power law here, we raise everything to the power of 3. So that's going to be 5 cubed, n cubed, because obviously that's n to the 1. 1 times 3 is 3. And then p 3 times 3 is 9. Okay, but actually we could simplify 5 cubed, isn't it? Because the 5 cubed is 5 times 5 times 5, which you should know. You can put it into the calculator, but hopefully you should realise that's 125. So this actually goes to 125 n cubed p to the 9. Okay, and then for part C, we needed to simplify this. So again, with division, the power law, if you're dividing the number by the same number with different base, instead of adding them like with times, then you subtract them. So it's a to the m minus n. Okay, so with dividing expressions like this, do it bit by bit. So first of all, we recognise we have 32 over 4, which is 8, right? I then recognise we have q to the 9 divided by q to the 3 here, right? So then that's q to the 9 minus 3, which will be q to the 6 via this power law here, right? So you subtract the powers. And then we have this last bit here, r to the 4 divided by r, just r to the power 1, really. So that's 4 minus 1, which should be r cubed. Now we bring that all together, so it's going to be 8 q to the 6 r cubed. Okay. And yeah, so that's that question. Okay, question 2. Now I'm going to bring the calculator up for this. So again, these sort of calculator questions where they just ask you to put stuff in the calculator are very typical. So you just got to make sure you know how to use a calculator, but you should have used all these functions in your calculator before. You should have square rooted stuff, you should have squared stuff, you should have times, you should have used sine, okay, in trigonometry. So all of this should be familiar functions, right? Familiar in things you put in your calculator, so it shouldn't scare you too much, hopefully. Okay, so work this out. So firstly, I'll show you what to input here. So we have a square root first, so have a root. Then we have a division. So it's kind of like bid maths, right? You do kind of like the order first. So the square root, remember, is the same as saying a to the half. So that's an index. So via bid maths, the indices should go first, then the division, which is a fraction, then any multiplication. Okay. Anyway, so I did the square root first, then I'm going to do the division. Then I'm going to do the top bit, which is 2.5 times sine here are 43 degrees. Then I do the denominator, which will be 8.2 squared minus 50.5. And I put that into the calculator, I get this number here, 0.31. Let's just note it down. 0.3191419855. Okay. But then it says correct three significant figures. So we need the first three numbers essentially that are not zero. So obviously 3 is the first non-zero digit, then 1, then 9. Then the next number would be 1, but that's not higher than 5, or 5 or higher. So that will just remain as 0.319 to 366. Okay, cool. So that should be just fairly bog standard using the calculator, right? Okay. On question 3 now, Venn diagram question. Um, okay, so we need to fill all this information into this Venn diagram here. So again, what I like to do with this sort of thing is firstly consider the numbers we've got to work with, right? So this little weird Z symbol, this really weird symbol here, this really fancy like calligraphy or whatever, that means every single number, every single thing we must consider. So here, odd numbers less than 30. Um, that means we have to consider the numbers 1, 3, 5, 7, and then so on to 29, right? 29 is the last odd number, less than 30. So these are the numbers we've got to consider, right? And also the dot here, there's more numbers. Okay, so every odd number between 1 and 29. Cool. So then we have A, and the total to set A is just purely 3, 9, 15, 21, 27, and B is 5, 15, 25. So what we need to do is, and actually they haven't given us, actually they haven't labelled the circles for us, but we can do that easily. So this circle be A. So A is just a list of numbers. So, this circle represents the list of numbers in A, and the other circle is B. So this will be to represent every number in B. Okay, so the best way then to fill in a Venn diagram is to, again, start from the middle and work your way out. So in the middle is when they overlap, they intersect, which means every number, which means all the numbers are both in A and B, because obviously this part here would be in both the circles, so it has to be in both the lists A and B. Okay, so what numbers are in A and B? Let's have a look. 3. 3's only in A. 9. No. 15. 15's in A and B. So we can put 15 in the middle. Cross it out. Then we're 21. No. 27. No. So 15's the only overlapping number. So then what numbers are only in A? Well, it's going to be 3, 9, 21, 27, right? So those are the outside numbers that are only in A, that are not in B. And then similar for B then it's just going to be 5 and 25. Okay, so the remaining numbers in B after we got rid of the overlapping numbers. Okay, cool. Um, so those are numbers in A and B, but that's not all the numbers we have to consider, because remember, these are the numbers we must consider. But these are only some of them. So then what we have to fill in and what really the Venn diagram represents is everything inside the box has to be has to contain all of these numbers, right? Every single one. It's called a universal set, which means like universal. It has to be everything. Every possible number outcome has to be in this box. So if a number is not in A or B, it has to be outside. It has to still be in the box, but outside. So it's going to be in this space outside. Okay, so let's just note what numbers are not in A or B. So I guess let's just go one by one. So 1 is in neither. So 1 can be outside here. What about 3? 3's in A. So that's not 3. What about 5? 5's in B. So not 5. 7. Well, 7's in neither. So 7 has to be outside then. 9. 9's in A. Then 11. 11's in neither, so 11 be outside. 13, 13's in neither. 15, 15's in the middle, so no. 17, 17's in neither. Circle, so leave it there. 19 is in neither either, so 19 be outside. 21's in A. 23 is in neither, so bring 23 out here. 25 is in B. 27 is in A. And then 29, the final number. Well, it's going to have to be outside as well, isn't it? Okay. So yeah, these are filled in Venn diagrams. Now every number that we have to consider, right? This in this weird Z symbol, which universal, all everything you have to consider. All of these numbers in this list are now filled in the box. So that's complete now. Cool. That's 4 marks as well. Okay. So then it says a number is chosen at random from the universal set, which again it basically means everything inside the box. So what is the probability that the number is in the set A or B? And that I just said it there. It means or. So this U shape means a union. Okay, but that means or. So it means it could be either or. So A or B. So it's like how two things can be like consider two things together. It's kind of like the union, right? So it means or. In a weird way, I like to remember it because a U shape really like sounds a bit like an U, like or U, or like it has a really similar phonetic, like really similar sound to how you pronounce or to U. I don't know. That's a bit of a reach, but that's how I like to remember it. In the same sort of way, the other thing you need to consider sometimes is my phone. The other thing you need to consider sometimes is this shape here, N. This little N shape, and that means the intersection. I didn't get that. Could you try again? I don't know what she's doing. And that means intersection. Um, and that means actually and. Okay. That would mean it has to be in the middle, right? A or B, A and B. And I like to remember that because it has just like an N sound. It's like and, like an N, right? I don't know, that's how you remember it. But those are the things you got to be aware of, really. But for this question, anyway, we have or, so it has to be in the circle A or B. Well, it has to be in A, which is here, or B. So it can be in either circle. But it has to be in one of them at least. Well, it's going to be the numbers in either circle, right? So it's going to be 3, 9, 21, 27, 15, because although it's still overlapping, it's still in a circle. And then 5 and 25. But how many numbers is that then? Because it's a probability. So that's going to be 1, 2, 3, 4, 5, 6, 7. And then out in the total, well, how many numbers are in total? So there's 7 in the circle, but then there's 8, 9, 10, 11, 12, 13, 14, 15 in total, right? So that's our probability, 7 out of 13. So remember, it's just the numbers that we want out of the total numbers we have. Okay, that's probability. Oh, okay. Question 4 now. Okay, so we give it, so this error interval, so we have a number n, which is rounded to two decimal places, which is 4.76. And we need to write down the error interval. Now, the error interval, I would spoke about this many times. I'm not a huge fan of the word. It just means the bounds, right? The upper and lower bounds of the number, right? The range of values it could be, so like the bounds of it. So, and it extends from the fact we've rounded the number, so there's a bit of like leeway either way, so there is an up and lower bound. So, to do decimal places, what I like to I'll give another way of explaining it this time. But I guess the way I like to consider it as well, 4.76, what would be the next second decimal place? It'd be 4.77, right? Likewise, go back by two decimal places, would be 4.75. Hopefully you can see we're going up every two decimal places by 0.01, right? So that's every two decimal places. So I guess if you put it in the number line and not in a way, we want a number where it's closer to 4.76 than 4.75. In other words, a number where it round up to 4.76 rather than round down to 4.75, and the upper bound where it would round down to 4.76 rather than round up to 4.77, the next number up. Okay. Okay, well, how are we going to do that? Well, we're going to it's the midpoint, right? It's going to be in between 4.76 and 4.77. So it's going to be 4.765 and 4.755. Okay. Hopefully you can see because in between 4.75 and 4.76. Hopefully you can see that. And that's our bound, right? So that's a lower bound between 4.76. That means it has to be less than. And less than 4.765, right? So this number here and this number here. So that's our up and lower bound. Okay, so the last thing we need to be careful of is actually think which numbers will round down. Well, 4.765, well, that number actually would round up to 4.77, wouldn't it? Because 5 is actually, it would make the 6 round up, right? Because anything that's 5 or higher would round up. So that actually, that number itself will not round down to 4.76. However, every number before it will, because the next number down will be 4.7649999, so on, which we cannot write down. It goes on forever. But that will round. So every number before it will round down. So it has to be every number has to be less than 4.765. However, 4.755 we can have because even that will round up. That will round up to 4.76, right? Because 4.75, and then a 5 trigger it to round up to 4.76. So that it actually can be equal to that as well, because that will still round up to 4.76 to do decimal places. Okay. Yeah, I don't know. I feel like it's a bit awkward explaining that. I don't know, but hopefully that's helped. I did explain it a different way last time, but I'm trying to think of another way of doing it this time around. But yeah, so it follows the same sort of format every single time, right? So you need to usually they do give you inequalities, but obviously this time around they're a bit nasty. So you have to remember which way round it is. And you need to remember to include an equal sign because if it's a lower bound, remember this lower bound here will round up to 4.76, but this number will not. So they cannot be equal to this one, but it can be equal to the left, to the lower bound. Okay, so that's your lower bound and your upper bound, right? And yeah, that's error intervals, right? Just the intervals of the bounds. Okay. Um. Okay, we're gonna move on. Question 5. Okay, so now it's asking about density. So the density, we're given density of an apple juice, the density of a fruit syrup, which is this, density of carbonated water is 0.99. We are given the volumes of each of these and the total volume, which is 320. Okay, so the density, and we're given there's grams, there's mass, and there's volume. So you really need to know this little expression here, this triangle, MdV. So this is your mass, your density, and your volume. Okay, and you do need to remember this. I'm pretty sure. So you need to know this is mass, the V's volume, and your D is your density. Now, if we want density, we cover that up. So then you're left with M over V. This line is a division, okay? So this is saying D would be M over V, M divided by V. So that's what we're going to do. So we're going to work out the mass and the volume, then divide it, okay? But we want the density of the drink. So the drink here, if you see, is all these three parts together, the apple juice, the syrup, and the water. All these three combined together. Now, what you cannot do is just add the densities together individually. You can't do that. But what you can do is add the masses and the volumes together, right? Because if you add one thing and then add another, the spaces are gonna add together, right? The volume they occupy. Same as the mass, right? You weigh one thing, then add something else. The mass will add together. So the masses and volumes will combine, but not the density. Because that's the key thing here. So we need to then work out the total mass, don't we? But the total mass we don't have. So we're going to leave that there then, but we do have the individual information about the densities and the volumes of each component, right? So let's work with the apple juice first of all, the apple juice. We know that the density is 1.05. We know the volume is 25 centimeters cubed. Therefore, well, the mass, again, if you cover the mass up now, that's just going to be density times volume. So it's going to be D times V, which is going to be 1.05 times 25, and that will be 26.25. Cool. Now we do the same for the fruit syrup. So the fruit, again, we're given the density to be 1.4 grams here, and we are given its volume here to be 15 centimeters cubed. So therefore, your mass, in the same way, you times them together, 1.4 times 15, and that will be 21. Okay. And then lastly, we have the water, right? The carbonated water. Again, the density of that is 0.99. The volume is 280. So therefore, the mass of the water is going to be, or the M, is going to times them, right? 0.99 times 280. And that will be done. Okay, I'm gonna do the. I already pulled up the calculator, by the way, to help with that calculator question, but it does slow down my laptop, I think. So I'm gonna do it on my calculator in physically, right? As but I tell you what, obviously, as I go along, what I'm putting in. Okay, let's create more room here. Anyway, so the math when you do that time is 277.2. So now we have the mass of all three of them. So now the total mass, if we go back, oh, we'll do it here actually. So the total mass, which is the mass of the whole drink, you just add all the masses together, right? So it's going to be 26.25, add 21, add 277.2, and that will be 324.45. Cool. And the total volume, so what's the total volume? So the volume that all three of the drinks occupy, right? The volume of the individual drinks, we add them together. But the total is, so the volume of 25, 15, and 280 is the total volume for each 20. They're actually giving us all that here, actually. So it's 320. If we add them all together, the 25, 15, and the 280. So now you have the total mass and the volume, you can get the density, the overall density, right? So that's going to be then the mass over the volume, remember here, which is going to be 324.45 divided by your volume of 320. So you put that into the calculator, you get 1.0139, blah, blah, blah. And it says for 2 decimal places here. So to do this, right, it's going to be 1.01, and that'd be grams per centimeters cubed, right? So your mass over your volume, your units, to 1 to 2 dp. Okay, cool. Hopefully that shouldn't be too bad. So that's the central idea of these sort of density problems is you cannot add the individual densities together. You can't do that. You have to consider the total mass and the total volume, then do that mass over the volume to get that density. But the mass and the volume you do add together. Okay, but the densities you cannot. Okay, cool. Okay, so we're on a box plot now. So it says the box plot shows information about money spent by male students on holiday. Okay, it doesn't really matter what's going on there. We just need to read what they're asking us to do. Okay, so it says for part A, work at the interquartile range of this. Okay, so the interquartile range, or the IQR, it's going to be you should know it's going to be the upper quartile minus your lower quartile. So then we need to find what the up and the low quartile is. Well, they're giving us the box plot, so you should recognize with a box plot that this is your upper quartile and this is your lower quartile. So where the box starts and ends, that's obviously the lower and the upper. Okay, so then what we need to do is read off the graph. So the upper quartile is in the middle here. Okay. So that's about every box then. What does, again, you need to work what each box represents. So one box will be, it's going to be 10, right? No, sorry, 20, because there's 5 boxes every 100. So 100 divided by 5 will be 20, yeah. So that's going to be 320, and then this is in between, this is the middle of a box. So that's going to be 330. So your upper quartile is going to be 330. Hopefully you can see that, right? So it'll be very, very fine. But yeah, it's 1.5 boxes away from 300. So half of a box is obviously going to be 10. So 20 add 1 is 10, add 300, 330. Okay, now we're going to do the same for the lower quartile. Again, it's in the middle here. Uh, in the middle of a box. So it doesn't make it easiest for us, does it? So it's going to end up there. So that's about 2.5 boxes away. So that's going to be 150, right? Uh, Yes, 120, 140, then 150 in the middle. So your lower quartile is 150. Hopefully you can see that. Um, and so then you just do the sum. So that's going to be 180. And that would be your lower quartile. 180 pounds. Cool. Okay, then it says the table below shows information about the distribution of by female students. And they're giving us the data, and we need to plot the box plot for this. Okay, so again, you just need to plot all this information in. I'm going to get rid of these lines now, just to make sure that they don't get in the way um, of this. By the way, next example, I would recommend doing the pencil. I guess it looks better than, I don't know. Well, you could use a pen, but pencil in this case would be good because you can rub it out a little bit if you do any rough workings. Um, but yeah, anyway, so we are given. I'm going to do the box plot down here somewhere. So the box plot, so the smallest is 60, the smallest value. Let me get rid of this. So we need to find where 60 is. It's going to be here, right? This little line here. So it's going to be about there, right? This line here. So that's your minimum, your smallest, and your lower quartile is 180. Then draw another line. That's going to be here, right? Because that's going to be 180. That's going to be 60 again. Then the median's 300. Well, 300 is nicely here, right? That's pretty obvious. That's 300 the median. The upper quartile is 350, so that's going to be, again, up here, isn't it? So it's like the midway of a 2.5 boxes away. So that's your upper quartile, and then your largest value will be 650. Again, that's going to be 1, 2. It's going to be here. Yeah, thereabouts. Okay, so we plotted all that 5 data. Now we just need to connect them and draw a box plot. So between the minimum and the lower quartile, so there's the line in the middle. Then you draw a box from the lower quartile to the upper, likewise there again, and then we draw a line from the upper quartile to the max. And you should notice if we were a bit stuck, they're quite nicely giving us another box plot as an example. So it should match this. Okay, cool. Obviously, by the way, I don't the thickness, not the thick, the how thick it is doesn't matter as long as you get the lines in the right place, in the right in the right place, right? Doesn't matter how deep it is, how far or how much you draw it. So obviously, mine one's a bit stretched out than this one, right? This box top, but it doesn't matter as long as the actual values are in the right place. Okay, cool. Yeah, so I guess the key central thing with this sort of box plots is actually to work out the scale, so how many boxes, what each box is worth, right? Okay, cool. Okay, now we're given, Chris says, the box plot shows that the female students spend more money than male. So I should say what we worked out in part B, remember, that was the female students. So that was male, so this will be female. Okay. So we need to compare. So what does it say? It says female students spend more. So actually, when it's talking about that, it's talking about the averages, right? So it's asking us to comment on the average. So then, and you should know with box plots, the average is the median. Okay, cool. So with that in mind, which box plot has the highest median? Well, it's going to be females, isn't it? Because the median here, this median line, is far more along than this because the median here is 300, remember, but the median here was about 250, right? So obviously, therefore, the female median spending, should we say, is higher than male spending. And you could actually be a bit more specific and say, since 300, which is the female median, remember, 300 is greater than 250, which was the male one. Therefore, female students spend more than males, right? Because on average, that's what happens, right? That's what the box plot shows. Cool. So that's all you need to come on. So with these sort of explanation questions with box plots, you either need to talk about the average, which again is the median, or they want ask you to comment on the spread. Now this time they didn't. The spread, like we did in part A, is the IQR. So if your box plot has a bigger interquartile range, that's telling you the data is more spread apart. So it's less clustered together. So for example, if a data was all like this, it's quite clustered together. But if a data is more spread out, like a scatter graph or something, then it has a wider spread. That means the data is on average further apart from each other and the further away from the average. So there's more variance, okay? The range is higher. But here we're just on about the average. But hopefully that made sense. Hopefully. But we're going to move on now. Okay, so this one now is on about pressure, force, and area. So we are given a force of 70 and an area of 20. Immediately then I can compute the pressure, but I'm going to read the question first. The force is increased by 10 and then the area is increased by 10. And then Helen says the pressure decreased by less than 20. So what's happening is we have an initial pressure um, which is this starting bit, right? So let's work that out. So initial pressure is force over area. We're using this formula, and they will give you that. So that's going to be 70 over 20. And then you put that into the calculator. That will be 3.5, right? That should be pressure at the start. Then it's saying the force and areas change. So the change pressure. Well, the new force is increased by 10. So it's going to be 70 at 10, which is 80 for the force. And the area is also increased by 10. So it's going to be 20 add 10, which is 30. So your new pressure or your change pressure will be 80 over 30, which is 2.66. Okay, this is recurring decimal, but it doesn't matter. Okay, so what we need to do then she says the pressure decreases by less than 20%. So we need to find this percentage change, right? There are a few ways you can do it, but actually I think the way that makes sense to me is, well, really, when we're saying the percentage decrease, well, that would say if you should be really comfortable with multipliers by now. So our initial pressure is 3.5, and it's being decreased by some multiplier, which is x here. That multiplier represents the percentage change, and that will then lead to a change pressure of 2.66. So therefore, your multiplier is going to be if you divide by 3.5 to solve for x, that's going to be 2.66 recurring over 3.5. And you put that into the calculator, that will give you this number here, 0.7619. Okay, or just 0.76 to 2 dp. Okay, that represents the percentage. That represents the amount of the original, right? That is 76%. So that's 70%. That's saying it's 76% of the initial pressure. So therefore, the percentage decrease is going to be 1 minus that. It's going to be 100 minus 76, which will be 24. Okay. Okay, so that's your percentage decrease then. Hopefully you can see that. So this multiplier is telling us, like with any percentage question, the amount of the amount that the pressure's decreased to. Okay, so this is telling us that this 2.6 is 76% of the initial pressure, but so then the percentage decrease is the whole 100. So how much have we lost? So we started from 100% and then we've gone down to 76. So our decrease then is minusing, right, to get 24. So that's your decrease. But actually, it said the percentage decrease is less than 20. Well, 24 is obviously greater than 20. So therefore, Helen is wrong. Well, I guess if you wanted to just say as 24 is greater than 20. Okay. I don't know, but she must be wrong then. But yeah. Okay, so question 8. Um, okay, so it's a compound interest question. I spot that because it says compound interest. So she said this Niobe invests 6,000 for 5 years, and this investment gives a compound interest of X% per annum. So first of all, you should know annum means per year, and also the way compound interest works is you add a certain percentage on every year. Okay. Um, and we'll see how that works in a minute. And then at the end of 5 years, it's worth this amount here. Okay. So those are the things to bear in mind. Okay, so what is going on here? Well, we start with 6,000, and again, like with the last question, we have a multiplier out of x. So if we're increasing the amount by a certain percentage, we times by a multiplier, And at the end of year 1, it's going to be some amount, right? We don't know what it is. And that's the end of year 1. Now, year 2, let's think about this then. Year 2, it's this amount, right? 6,000 times x, which is times x, right? So that's the year 1 value. But then think about it. For year 2, the next year, we still had to add on x% of that. That's how compound interest works. So again, we're going to be timed by the same multiplier, x, because that will raise that amount by x%. Okay, and that'll be then again equal to something else. That'll be year 2. And hopefully then you can spot in the third year, 6,000 times x, right? That's our second year value. Then we're going to be raising by x% again, so we times it by x. That'll be, again, we don't know what that is, so that'll be year 3. And then year 4 again, 6,000 times x times x times x. And then we're going to be raising by x%, so times it by another x. And we don't know what that is. So that's for year 4. And then for year 5, we're doing it again. So 6,000 times x times x times x times x. And then we times it by x. And all of this again is being increased by x%. Actually, we do know what this is because this is year 5. This is now 8,029.35, and that's year 5. Okay, so what we can do now is simplify this. So 6,000 then. Now we times an x by itself 5 times, right? X times x times x times x times x. That's 5x times itself 5 times. That's going to be times x to the 5. Okay. Again, you can think of this even in terms of index laws. So if you're times in by the same number, you add the powers. Well, it's 1, add 1, add 1, add 1, add 1. That's 5. Okay. But anyway, so that times x to the 5 is 8,029.35. We can now solve for x, can't we? So if we times it by 6,000, let's get rid of it by dividing by 6,000, and then left with x to the 5 is 8,029.35 divided by 6,000. Actually, I'll be consistent here. Over 6,000. And that will be, put that into the calculator. This number here. 3325. But that's x to the 5. So therefore, x then, so we have, if that's the 5th power, we're going to need to do the 5th root, okay? So it's the 5th root of 1.33, what we just had. And then we put that into the calculator. And then you get this number here. X is 1.0599, and so on, so on. Okay, so that's our multiplier. That's not our percentage, though. I should have used a different number, actually. I should have used y. Oh well, but that's our multiplier. Our percentage then, how are we going to get this a percentage? Well, you just times by 100, right? So there, that's the same as do it here. That's the same as then. Well, that's 1 at 0.599. So the percentage increase is 5.99%, right? Increase. Okay. And actually, I'll just say to make it more clearer, this is actually going to be on the calculator. It's actually 0.59999, so on. So actually, this rounds to 6%, really. To, I don't know, 2 dp. Because obviously 9 to 2 decimal places, but the next number's 9. So it will keep rounding up to 6. Okay. So that means x is 6 here. This x% is 6%. Yeah. So that's what we're increasing it by every year. Okay, but the alternative way, once you are comfortable with these sort of questions, rather than do it year by year, you could just do it all in one go. So you could realise again here, You're having 6,000 and you're raising it by the same percentage every year for 5 years. So it's going to be times x 5 times. And then the final result is this, and then you can just do it from there. Okay, that's the far better way of doing it, but I've broken it down to see why it works and how it happens. Okay, um, but yeah, hopefully it made some sort of sense now. But yeah, I think the thing I realised as well is this bit here. This is this would be actually be 105.99%, but obviously we started with 100%. And then we added on our 5.99%. So our increase is 5.99. Okay. So we take 100 or 1, depending, away from it to get the increase. Okay. Cool. Okay. Now we have a ratio question. So we have 4 boxes on the shelf, A, B, C, D. We're given some information about the weights. Okay. Uh, and then we need to find this ratio. So we really need to find like weights of A, B, and C and D, kind of. Okay, so we need the ratio of all of them. So the best way, there's a lot of stuff going on here. So the best way is actually to start forming some equations. So let's convert this information into stuff we can work with. So if we say A, B, C, and D are obviously the weights, then the total weight of A and B, well, what's the total weight of A and B? It's A and B combined, right? A and B. The total of this is 3 times, it's with 3 lots of the total weight in C and D. Well, that's C and D, so C add D, right? So 3 lots of weight of C and D is the weight of A and B. So that's the first equation, and then we can expand that to say 3C add 3D. So that's this part here. Cool. Um, okay, then we are given the weight of A is 2/3 the weight of B. That's simply A is 2/3 of B. Okay. And then we're also given the weight of C is 75% the weight of D. As a fraction or decimal, that is 3/4. Okay. You should hopefully recognize that. So by that logic, C is going to be 3/4 lots of D. Okay, now with all of this, we've got to find this ratio here. So I think the best way to do it is find everything in terms of one weight. But I've noticed here, because we've got equations here, I think we can substitute this into here and see what happens. So if I sub A 2/3 B into there and C is 3/4 D into C here, well then we're going to get 2/3 B add B is 3 lots of 3/4 D add 3D. And then 2/3 B add another B, that's going to be 5/3B. And so then this will be 9/4D add 3D. So 5/3 B is 9/4 add 3. And that's going to be 21/4D. Okay. Now actually, we can actually write to the ratio of B to D. But I think the best way, because I believe you could then say the ratio B to D is going to be 5/3 to 21/4. Okay, so for every 21/4 lots of D, you get 5/3 lots of B. That's what this ratio is saying, which is exactly what is happening here. But I think we can simplify this. So I think if we then what I love to do with these ratio questions is write the ratio in the form of 1 to n or n to 1. So some lots of one of the ratio parts has to be 1. And the best way we can do that is actually scale it by dividing by one of the numbers. So I think D's are nasty, so let's get rid of D. So let's make D 1. So then we have to divide by 21/4 to both parts of the ratio. So 5/3 divided by 21/4, put that in the calculator, you then get 20 over 63. Hang on, hang on. No, is that right? 5 over 3 divided by... No, no, that's not right. My apologies. Uh, no, so I'm going to stick with what I was going to do before. So I jumped a step there. So what I'm going to do is actually, there's two fractions on both sides. So I'm going to simplify it to just say b, and then I'm going to divide by 5 over 3. So 21 over 4 divided by 5 over 3. That will just be left with b equals this number here. 63 over 20d. Okay, hopefully all I've done there was divide by 5 over 3 to get rid of the b. Doesn't matter which way you do it, but they do it either. Now that is a ratio we can easily convert, okay? Rather than having two little different fractions going on. That's saying for every 73 over 20 lots of d, we have 1 lots of b. That means that the ratio b to d has to be 73 over 20, 63 over 20 of lots of d, because for every one lot, for every d, no, one, sorry, because then for every d, every part of d we have 73 over 20 lots of b because of this formula here. That's what that's what this ratio is telling us here. We can convert between. Hopefully you can see that right. Okay. So the best way to see it, this is why I love putting it in the form of 1 to something. Because say if you substitute d 1 now, say if d is 1, b would be 73 over 20, 63 over 20. That is clearly what we've got going on over here. So cool. So we've got a ratio b to d. What we want is essentially the ratio a to b to c to d. So we've got one part. Um, okay. But we know, but we've got B to D, so we're going to have to put we also know C to D, because this bit here would then convert to C, to D would be 3 over 4 to 1, wasn't it? Because again, say if D was 1, then C would be 3 over 4. So for every D we have, C would be 3 over 4 lots of D. That's what this ratio is telling us. So now we have the ratio C to D, and we have the ratio B to D. All we need now is A to D. Okay, so we can start by well, we can say so we know this ratio is going to look like 1 to 3 over 4 to 63 over 20. Now we need something for A. Okay, but the only thing we have for A really is 2 over 3 lots of B. But we can but then we know we can find A in terms of D because we have this expression too. So if we substitute B in for A, get rid of this, that is equal to 2 over 3 lots of 63 over 20D. Okay, happy with that? Because I'm substituting this into here for B. So now I've got A in terms of D as well. So what I'm doing is finding almost like a common number, common denominator. That sort of equivalency, right? That sort of idea. I'm finding one common number, which is D, and then I'm expressing a ratio just for A, B, and C to D, okay? And then I can bring them all together because they all have the same number in common, but you just bring them all together. That is what I'm doing here. So I've found B to C, which I've boxed and highlighted. Now I'm just finding A by doing this, okay? So if I have a formula, a link between A and D, I can find the ratio. That's what I'm doing here. So what's that? 2 over 3 times 63 over 20. You get 21 over 10D. So we have A is 21 over 10D. Therefore, the ratio of A to D is going to be 21 over 10 to 1 again. So again, you could say D is 1, then A would be 21 over 10. That's exactly what we've got here. So for every D, we have A is going to be 21 over 10 lots of D. That's what this ratio is. So therefore, we have the ratio 21 over 10. And now that's our ratio, right? A, B, C to D. I think you could leave it there, but I want to simplify it to a whole number, just for sake of argument. Well, the 4 and 10 going to 20, so I can just times by 20 either side. I'm going to do it here, times by 20. So then this ratio becomes 42. If you put times 21 over 10 times 20, you get 42 to 63 to 3 over 4 times 20. That'd be 15, right? Let me check that. It's 15. Then D would be 1 times 20 is 20. That is your ratio, A to B to C to D, the weights, okay? As it's kind of simplified, and I know it might be it is quite a nasty question, I'm not going to lie, but this is sort of the way you can approach a ratio question on sort of fundamental level, right? If, like me, because I struggle with kind of visualizing how you convert and get ratios. The best way, like I said, is try to make a common number, D, and then pull it in this form, a number to 1. Because if you do it like this, it's very makes it a lot easier to compare and see what ratios you need of what you get, okay? Um, and yeah, hopefully it made sense, right? Um, but yeah, that's the best. I don't know. That's I guess a more algebraic way of doing it. But in my mind, I think this is what makes the most sense to me, right? Again, there are probably multiple ways of tackling this, but I think this is the most systematic, I guess, the most sense in my mind, right? That breaks it down. Yeah, okay. And hopefully you can see what we've done here. So if I highlight this, so D is all lots of 1. So when D is the same number here of 1 here, then I can just bring the A, B, and D and C together like this. So A to D 21 over 10. So that's here. B is 63 over 20 to 1. So that's the 63 over 20. Then C to D is 3 over 4 to 1, which is 3 over 4. And because it's all to 1, we can bring them all together. And then all I've done here at the end, you don't have to, but I've simplified it to get a whole number. Okay, that's that question then. Cool. There will be a ratio question. There's a ratio question absolutely every single GCSE paper. It's one of those topics that it's so important to real life. They do just have to ask it anyway. So you need to be prepared for questions like that. But yeah, okay. Okay, we're on question 10 now. So Jack is in a restaurant now. 5 starters, 8 main courses, and some desserts. I'm not giving us that number, but there's some desserts on the menu. He's going to choose 1 starter, 1 main course, and 1 dessert. So there, he says there's 240 ways of choosing a starter, main course, and dessert. Is he right? Okay. Well, again, it's a combination question, isn't it? You sort to pick these up right. This sort of when you practice and do loads of these sort of questions. So what's happened is, I'll say our menu here, a list. Again, with these sort of questions, you break it down into a list. So we have a starter list. We have a main. Oh God, a main course list and a dessert list. Main and starter. Okay, I'm just gonna leave it there, starter. So what's happened is from each one, obviously the first starter, I can pick one from the main, of any of the main, and then any from the dessert. So what that means is the total combinations is going to be the amount on each list, right? The size of each list, how many items are in each list, and then times them. We know there are 5 starters, so 5, and then 8 courses, and then some desserts. We do not know how many there are, so let's call it X again. So there's some X amount of desserts, and that will give us a total combination we can pick from, okay, from each menu, right? and it tells us that 200, it could be 240 ways. So if that is true, let's equal that to 40, and then let's see what x will be. So x is going to be 240 over 5 times 8. Okay, if we rearrange and put that into the calculator, you get 6, okay? Well, 6 is a perfectly valid number, right? It makes sense. It's a positive number. It's quite small, I guess. But it's a positive integer. It's a positive whole number. So it is. There can be 6 desserts. There could be 6 desserts, right? So Jack could be correct, right? Now if we had to say like if this came to like 6.24 something, for instance, say, then that couldn't be right because you can't have part of a dessert, right? You can't have a decimal of a dessert. You have to be a whole number. And if it was well, no, you can't get a negative here. But yeah, you just have to be. You have to kind of reason real life and stuff like that. So you can't have a decimal. But 6 seems perfectly normal, right? Of that amount of desserts that you can choose from. So it can be right, all right? It all makes sense, okay? The whole idea is to use combinations, right? So this is also called the product rule of counting because it's a product, right? So you times all the items together, the amount there are in each list, to get the total combinations. Okay, cool. So now on question 11, and it's a triple bracket. And there's really nothing to be afraid of in triple brackets. A lot asking them every year, but they're not a big deal, really. So with triple brackets, again, you just split them up in parts, right? So you know how to expand double brackets. So let's do the first double bracket, right? So this you should expand in normal methods. So I don't know if you use FOIL or whatever, but that would be 2x times x, which should be 2x squared. And then 2x times 3, which should be 6x. Then you had 1 times x, which would be just x. And then you have 1 times 3, which should be add 3. Okay, we can simplify this, can't we? So that'd be 2x squared, add 7x, add 3. And then this gets times with the other bracket of 3x plus 7. And then you do the same sort of thing again. So you have to times, again, each part of each bracket together. So firstly, it's going to be 2x squared times 3x, which would be 6x squared, cubed, sorry. Then you get 2x squared times 7, which would be 14x squared. Then you're going to have 7x times 3x, which would be 21x squared. X times x is x squared, remember. Then you're going to have 7x times 7, which would be 49x squared. Then you're going to have 3 times 3x, which should be 9x. And then 3 times 7, which should be 21. And so we can simplify that to get 6x cubed, then collect the x squared terms. Hang on. This shouldn't be 3x squared terms here. 20 plus 49x. There we are. Don't know why I added an x squared there. And then 14 add 21x is going to be 35x squared. Then we have 49 add 9 is 58x. Add to 21. And that is in this form here. So that should be right. Okay, so yeah, that's the idea behind that. Okay. So we're on question 12 now. So this is a quadratic sequence and is asking us for the nth term. So I'm not going to go too much into the theory behind it, but the method. Well, write the list again. What you can consider is the first difference between the numbers. So that would be 6. Then that would be 10. That would be 14 between 15 and 29. 29 and 47 would be 18. and 3 was 47, 69 would be 22. Now, this will not be a fixed number, but then if that's the first difference, but then if you take the next difference, you can spot this is linear, so it's going to be 4, 4, 4, 4, and that will be a fixed number. Now, what this tells us is actually 2a, so I should say the nth term, remember, is going to be of the form an squared bn plus c, because it's a quadratic, right? So it will have a quadratic sequence, right? The n in a quadratic fashion. So our a coefficient here, well, 2a is going to be this number 4. You can think of it, if it helps, to think it's a second difference, so it's going to be 2 lots of a. You can think of it however you want, but I think maybe that's the best way of thinking about it. The second difference, so it's going to be 2 lots of a. Therefore, a is going to be 2 if you divide by 4. So therefore, we found our sequence, part of it, which is 2n squared and bn plus c. Cool. So what we're going to do now, I'm going to write this again. The sequence -1, 5, 15, 29, 47, 69. Then what I'm going to do, then I'm going to consider the sequence 2n squared. So this happens when you substitute 1, 2, 3 into n. So what this will be, so the an squared part, right? So 1 will be 1 squared times 2, that'd be 2. 2 squared is 4 times 2 is 8. Uh, 3 squared would be 9 times 2 is 18. 4 squared would be 16 times 2 is 32. 5 squared would be 25 times 2 is 50. 6 squared would be 36 times 2 is 72. Okay. Now what I'm going to do is you subtract them together and you'll notice what happens. So then you subtract them term by term. -1 -2 is -3. 5 minus 8 is -3. 15 minus 8 is -3. 29 minus 32 is -3. -3 -3. Okay, now usually this is a linear sequence you get. And the reason for that is actually, isn't this term here, this sequence, 2n squared plus bn plus c? If you're then taking it away by this 2n squared, this an squared bit, well, that will cancel and you're left with bn plus c. So this sequence here is actually bn plus c, the linear sequence part. But actually, it's not going up by any amount, so that means b has to be 0. And so our c, if we go back, again, it's just be -3. So therefore, we found b and c, so our nth term is going to be 2n squared plus 0n, so you'd have -3. So that will be your nth term there. Okay, that's the method. I know I've seen this around recently where, what is it? You consider 2a is this, then what, a plus 3b is 6, and then a plus b plus c is -1. So the first difference and the normal. And then you substitute a into b to find b then c. You can do it that way, but this method you don't need to learn really any like particular formulas, you know. Obviously you need to know 2a is this, but if you, I don't know, you can recognize it's the second difference of 2 of a, and then you go from there on. Everything else should kind of make sense, in my opinion. But that's the method. That's one method anyway. I don't know. That's how I do it. I think that's what a lot of people do as well. But it's up to you, really. If you find a method that works and it's proper, then go for it. Okay. On question 13 now, circle theorem 1. Okay, so we are given, I've really the drawn everything for us. We're given this as a tangent. We need to show this. Okay, so with these circle theorems, so again, start with what is staring at you in the face. What can you apply first? Well, we're given a tangent, so that screams either tangent and radius are perpendicular, or the alternate segment theorem. There's really only two things you can use with the tangent, I believe. The two main ones, anyway. The alternate segment theorem. So what can we use first? Well, This is a really, really finicky diagram, but actually, this whole angle here is 90 because the tangent and the radius are perpendicular. So this angle here, angle DFA, this angle here, and this angle here, ADB, and X, that all has to equal 90. But I'll bear that in the back of my mind that this whole thing's 90. Okay, but let's see what else we can do. Well, the alternate segment as well. So, I recognise that I'm going to draw a really bad sketch here. Then again, we have a tangent here at D. So then we have a chord DA, right? That's our chord. So a chord, remember, is a line that goes through two circumference points, and it's the line that connects them. So a line that's in a circle essentially is a chord. Even a diameter has a chord, and it's the largest chord. So obviously the line that goes through the origin, the center. Sorry, but we have a chord here. And then if say this chord then goes to another point on the circumference, and then that line, that point then meets the tangent again, that angle made between that line and the radius and between the chord and the tangent, they're equal. That's the alternate segment. And that's what we have here actually. So we have actually this angle here. If we call this angle Z, that means uh this angle Z as well, right? So this is Z, that's going to be Z. So that is B, okay? Hopefully you can see that right. I've just simplified the diagram a bit to show the alternate segment theorem. So if we call that Z, then that's Z as well. Again, obviously, I don't really know Z at the moment, but I don't know. I'm gonna can we do anything with that? Well, actually, don't we recognise ABD is a triangle? So wouldn't this then be 180 minus Z minus Y? I think it will. And then I think this whole, again, like I said before, this whole angle, X add 180 minus Z minus Y, add Z, these all add up to 90 because as you can see, this is the radius here, origin here, and the tangent, this whole thing is a right angled. I don't know if the best way to, I don't know the best way to show it, but this means all these three angles that go between the tangent to the radius, all of that has to add up to 90. And that's going to be because, and then we need to write down each stage. We're going to need to write some more stuff down as well. But I'm going to say because, again, tangent and radius are perpendicular. But also we need to know that actually, we need to go back a bit because we did some work before. So if we say let Z equal angle again, we said Z was angle ADF. Hopefully you can see that here. This angle Z. Then this angle here in the triangle ABD is also equal to F, and that's due to alternate segment theorem, right? If you remember what we just discussed. And therefore, this angle here is because of the triangle, right? That adds up to 180. So angle ADB now is 180 minus Z minus Y, and that's as angles in a triangle add up to 180. So we justified everything now. But now we can simplify this equation and the z's cancel. So then we're left with x add 180 minus y is 90. Then we can say x minus y is 100 minus 90 if you subtract 180 to both sides. And then we can times by minus 1 to then say y minus x is 90. And that is exactly what they asked us to get here. So there we go, we've done it. Cool. So it's a little bit fiddly to spot, but hopefully they made some sort of sense, right? Because really the angles, you could probably use opposite angle theory, opposite angles, because we have a cyclic quadrilateral as well, but it's not needed. Okay. Really, but there are probably multiple ways of doing it, but that's the way that screams to me. So because we have a tangent, that's telling me a lot of stuff, right? That is telling me about the alternate segment theorem because we have a chord as well, and we have a radius, so we're going to have 90 degrees somewhere, and we have a triangle. So it all, we can work through it one by one, and then eventually we get to that. Okay. I know circle theorems are loads of people hate. I'm starting to become more fond of them now, to be honest, but I really do sympathise though. Okay, so that's for 3 marks. Then it says Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 minus 110 is 90. Well, that calculation's right, but can he pick 200 and 110 for what? For x, y and x? Um, I'm going to give an exam tip here. And when they ask stuff like this, usually 90% of the time the answer is no. Usually. So bear that in the back of your mind. But okay, so let's have a look. So y and x is y 200, x is 110. Well, I've spot again. We use the fact that y is in the triangle, right? Because we have to add this angle to 180. Angles in a triangle can only go up to 180, but y is in a triangle. Y is an angle in a triangle, so y cannot be 200 because it'll exceed 180. So actually, no. Again, no is not correct. No, as y must be less than 180. As angles in a triangle must add to 180 degrees, right? Yeah, so that's really it then for that. There we go. Now we're on question 14. So again, it's an iteration sort of question. Hopefully, if people are tuned into, and I really do actually recommend you tune into these revision streams from GCSE. By now, hopefully, you recognise a lot of the topics are the same, a lot of the same sort of questions. There is a reason for that because they all ask the same stuff every time and time and time again. So again, practicing past papers and stuff like this is a very, very good way to revise and boost your grades. Anyway, so we have iteration now. So really, with this sort of question, all the same really. We have an initial value and need to find the first, second, third value. Okay, so using this iteration, x1 then is going to be -2 minus 4 logs of x0 squared. But we know x0, so that's going to be -2 minus 4 over -2.5 squared. And you put that into the calculator. That would be -2 minus 4, lots of -2.5 squared, and you get -2.64. Okay, then x2, again, it's going to be, you don't have to write this bit down as long as you don't have to show that you're substituting x1 in. You can just use the calculator again. However, this is now the ands. I should probably show something. Yeah, I'm gonna do it actually. I'll show it actually. Hang on, let me get out of the screen. Uh, Hopefully it doesn't freeze my laptop though. Okay, I'm gonna show this. So obviously x1, remember, was -2.64. That was the value you get if you plug that in. Cool. So then what I'm gonna do is I'm gonna say this is now ands, right? So this is what I'm on about ands, and that is now x1. Now x2 again will be -2 minus 4 over divided by ands. Where is ands? There it is, and squared. Okay. Now, instead of typing in minus 2.64, you just put ands in, and the idea is you can use this multiple times and without changing anything. Because now x2 will be given to this number here, minus 2.57, 392, and you do actually have to write them all the digits down, unfortunately. 1028. Okay, cool. And then x3, and this is why you should do this, right, to save time. Then if because this is ands now, is now this x2, you can just press equals again to resubstitute x2 back in to then get x3. So x3 is going to be now minus 2.66037 255, right? Cool. And so that's all it asks us to do, x1 to x3. So then you just put that here. So x1 minus 2.64, minus 2.573921.028. If it doesn't tell you, with the iteration in particular, if it doesn't tell you what to round to, I mean, you might get away with it. I'll have to check the mark scheme. But with this sort of thing, because the accuracy is so important, you should probably just give all the digits, right? To really cover your bases. But normally they do tell you to round it to something, but not this time. Okay, then it says, Papa, explain the relationship between these three values and this equation. Um, okay. Well, it's not entirely clear at the moment, but I notice that this probably can be rearranged in a different way. So this is saying x is, I write it here actually, x is minus 2 minus 4 over x, right? Because there's no x ends here. So I can just knock off the ends, n plus 1s, just replace it with just x. Then I'll say x plus 2 is minus 4 over x. So therefore, if I times them both sides by x, you get x squared and 2x is minus 4. And then you get x squared plus 2x plus 4 equals 0. And is that not this equation here? So therefore, the roots for what this iteration is doing is showing a root, right, a solution to this equation here. But because this equation's the same as this, because we've just shown it, we rearranged it, the solution to this is going to be the solution to this cubic as well, this solution polynomial here. So therefore, x1, x2, x3, God's sake, are approximate solutions. And you need to know it's approximate because obviously that's the old idea of iteration, right? It gives an approximate solution, an estimate, right? It's not the actual solution, it's converging to the solution. But obviously, as you can see, we're getting closer and closer each time to like minus 2 point. You can see it's starting to converge to some number, but they're approximate. So you need to write the approximate solutions to the equation. Okay. Or you can call them roots. Doesn't matter. Okay, cool. So on question 15, so now we're given a triangle. I notice it's a non-right angled triangle. So again, with non-right angled, I either need to know the sine rule, which is sine A, or no, I should say A over sine A is B over sine B, or the cosine rule. Okay, those are the two things right in the back of my mind. So that's going to be A squared equals B squared plus C squared minus 2BC cos A. Okay, so it's saying for the length of BC. So what we have here is two sides, and we need another side. So we have three sides we're working with essentially. That means we need the cosine rule. Okay, because cosine rule works with all three sides here, A, B, and C. The sine rule works with two angles, and here we only have one angle. We don't care about any of the others, so it's cosine rule. So we call this x then. So that means, or you could just call it BC, doesn't really matter. BC squared by the cosine rule then is going to be 8 squared add 11 squared minus 2 times 8 times 11 times cos um, of 72, right? Because bear in mind, this angle A has to be the opposite to the angle we want to find out, which it is, right? It's facing this side here that we want to work out. So 72 is the angle here. If we put that into the calculator then, that's going to be 8 squared add 11 squared minus 2 times 11, 2 times 8 times 11 of cos 72. And that gets you this number here, 130.613009. That's BC squared, so therefore BC is going to be the square root, right, of 130.613. And then you square root your answer, you get 11.4286, which the three significant figures is 11.4. Because obviously 11, the third non-zero digit is 4, and then that will, because 2 is less than 5, it will remain 11.4. Cool. Then it says for part B to find the area, and that's very simple. So you should know also half AB sine C is the area of a non-right angle triangle. So sine C, so if you have an angle and the two sides next to it, that's the area, right? So that means the area is going to be a half times 8 times 11 times sine of 72. Uh, and that will be, put that into the calculator. You get this number here, 41.84648. And to three significant figures at around 41.8. Okay, in centimeters squared. Cool. So that's really that then. Fairly straightforward cosine rule, and I think. They don't really tend to overcomplicate it that much, really. Usually it's questions like this. So, yeah, sometimes though they do combine it. So you need to find like a missing angle or missing side first. So you need to use the sine rule, then you might need to use the cosine rule for like a 5 marker. I have gone over questions like that as well, where you need to use both rules. But this time they just needed a cosine rule, just one application of it. But yeah, that should be fairly straightforward if you practice. Should be if you're comfortable with the topic, should be a bad question. Okay, hopefully that makes sense. We're moving on now. Now we're talking about this. So a train has travelled along a track in 110 minutes, correct in nearly 5 minutes. He finds the track is set 270 kilometers long. He assumes that track is measured correct to the nearest 10. Could the average speed be greater than 160? So what you immediately should be recognizing, this is a bounds question because it's talking about units rounded or being correct to the nearest accuracy, right? Nearest 5 minutes, correct to the nearest 10 kilometers. So that's all about rounding and bounds, okay? So then the average speed could be greater. Well, we need to consider the maximum speed. That's the upper bound, right? So we need to consider upper bound of speed. Okay. But we know that speed, again, with speed, distance, time, you should remember this triangle here. Distance, oh God, speed and time. And again, like with density earlier, if you want your speed, again, you cover that up and you do distance divided by time. So d over t, or distance over time. Um, okay, cool. So I'm just going to leave it there for now, but we want the upper bound, right? But speed is obviously distance over time, right? Okay. So we are given the bounds, or the rounding of both the time, which is 110, and the distance. So time is 110, 110. Um, so we're going to need to consider the bounds, right? So if it's nearest 5 minutes, again, like I did earlier, consider the number before and after 110. So if we go every 5 minutes, the next one's going to be 115, and the one before that's going to be 105. Again, you need a number in between both of them, remember? So that's going to be 107.5 and 112.5. Again, if it helps, visualize on some sort of number line. So it'll be 110 and then 105, 115. We want the numbers that are round in between, that are around 110 on the lower bound, round up, and the numbers that are round down to 110 from the top. So that's your upper bound. And that's going to be in the middle, right? So your upper bound is going to be 112.5 and 107.5. Okay. So that means the bounds of 110 is going to be 112.5 and 107.5. Okay. Likewise for distance, that's again, that's 270 to the nearest 10. So 270, and then the next 10 is a 280, and then before that's going to be 260, right? And then obviously it'll go on. Again, we need to, the bounds will be in between. So it's going to be 275 and 265. Again, with the sort of number line analogy, if it helps. But those are the bounds, right? So 270, 275 is your upper bound, and your 265 is your lower. Okay, so now our speed is given by this. We need the maximum speed, right? And obviously the maximum speed is still less than this, then the speed as a whole cannot be above this, right? So our upper bound, or obviously our maximum. So our upper bound speed. Well, we want the maximum value of the speed here, of this fraction. Again, so you're going to want to maximize the numerator, so make the numerator as big as possible and the denominator as small as possible. So we want to take the upper bound for d, our distance, which is 275, over our smallest value for time, which is going to be 107.5. Okay. Um, Again, if you have to visualize this, think about two different fractions, right? 8 over 2. Uh, Obviously, make the, and then say 6 over 3. So making a numerator smaller and the denominator bigger. Which fraction will be bigger? Well, this goes to 4 and this goes to 2. So clearly this fraction's bigger. So this will give an upper bound, right? If you make the top number bigger and the smaller number smaller, the bottom number smaller, right? Okay, so that's your upper bound. But we need to pay attention to the units because this is in minutes, this is in kilometers, but we need it the speed in kilometers per hour. So that means that this is in mins and this is in kilometers. We need to convert the time into hours. Well, how are we going to do that? Well, you should know that 1 hour is 60 mins. So therefore, 107.5 minutes is going to be 107.5 times 1 over 60. Um, well, actually, hang on. Let me show this more clearly. So 60 minutes. There are many ways you can do it, but we want 107.5 mins, right? And convert that into hours because it's kilometers per hour. What are we to work out what we times by? Let's do 107.5 divided by 60. That is a really nasty number. 43 over 24 as a fraction. So we're going to need the times by 43 over 24, which is 43 over 24 hours, right? Because 1 times 43 over 24 is 43 over 24. That's the same as minutes, so we can just change this to 43 over 24 hours. Alternatively, what you could have done there, if that didn't make most sense, is let me make some more room here. So I'm gonna I'll rewrite it here: 270, 275, 265. Alternatively, again, you could say that 60 minutes is 1 hour. That should be clear. But then you could then say 1 minute is 1 over 60th of an hour, right? Then you can simply scale to 107.5 by times it by 107.5. Because obviously 1 times 107.5 is 107.5. So 107.5 mins, which we have, is 1 over 60 times 107.5, which you put that into the calculator to get the same result. Yeah, the same result of 43 over, oh God, where's my pen here? Of 43 over 24 hours. Okay, so that's what you got work with. So what we're doing then for our speed is 275 over 43 over 24. So 275 dividing by the fraction 43 over 24, that will get you this number here. 153.48 something kilometers per hour. So that's our max. That's our upper bound. Now, this is our maximum speed, if you will. That is less than 160. So Jake didn't say that, but so no, speed cannot uh be greater than 160, as obviously the upper bound is less than 160. As obviously 153.48 is less than 160. Cool. So hopefully that made sense. So yeah, that's the whole idea. That's the whole idea of bounds, right? You convert the bounds of everything you're given. So if it says correct to the nearest something, you do the round, you do the bounds, right, the upper and the lower bound. Then you work out which one you want to take. So like with the fraction stuff, if you want to make a fraction bigger, you make the top number bigger, so the upper bound for the distance, and you want to make the bottom number smaller, so the time will be your lower bound. Hopefully that's clear. Okay. But yeah, so let's move on to the next part. Okay, it's a bit messy here, isn't it? Let's get rid of this bit. So now it says Jake's assumption was wrong. Remember, I'll go back and check, but he said he assumed the track was measured to 10. But what he's saying now is the track is measured to the nearest 5 instead. Well, how it could affect the decision? Well, what that's going to affect our bounds for D, isn't it? So remember, our bounds for D is between 275 and 265. If it's now to the nearest 5, the bounds will then look like 270 to 2672.5 to 2767.5. You can check that if you want. Because it's going up in every 5 now. Let's explain. 270, then 275. Again, the midpoint is 272.5 now. So that's your bounds of 27, and likewise for 267.5. But actually, the upper bound for D, because remember, we took the upper bound for distance here for speed. The upper bound is now smaller. So our upper bound is going to be smaller for speed. So clearly that's not going to affect our answer. So no, won't affect answer, as the upper bound for distance and speed, I'd say, and speed would be lower. So max speed. So So speed would still be less than 60, right? Be less than 160 kilometers per hour, right? That won't affect the decision because the number is actually getting smaller. So our upper bound for speed, because we're divided by a smaller distance now, 272.5 is less than 275. So our speed upper bound would be lower. So obviously that would still be less than 160. So it won't affect our answer. Okay, cool. Okay. Oh dear, now we got this sort of fraction question. They love asking a really weird fraction question like this. But once you break it down and know what you do, what you know, it shouldn't be too bad. Okay, so what I'm going to do first is let's work inside the bracket. So let's do this part first. So you have x plus 5 divided by x squared. Divided by, need to make that a bit more clearer. Divided by, there we go, x squared plus 3x minus 10 all over x minus 1. Now we are dividing, which means we have to keep this first bit the same. We need to change the times and we need to flip the fraction. Remember KFC. So x minus 1 over x squared plus 3x minus 10. Then we can times across to say that this is the same as x plus 5, x minus 1 all over x squared plus 3x minus 10. Now at this point we should check if it simplifies. So the key strategy, the key tip with these sort of questions with algebraic fractions, you need to factorize the numerator, the denominator, factorize anything really that isn't factorized and try and factorize it, see if it cancels. Okay, so here, do a little side note, x squared plus 3x minus 10. We need to see that factorizes. Obviously, you can use calculators or whatever, but obviously the way to do that is check the factors of 10 minus 10, right? So obviously 10 and 1 go into it. Oh, let's just do 10. 10 and 1, uh, 2 and 5. And what we need to check is the factors that could add in some way to get 3. And I think this can. If we choose positive 5 and minus 2, that plus 5 and minus 2, that will add to give 3, 5 minus 2, and time to give minus 10. So that is our factorize of x plus 5, x minus 2. So that means this simplifies to x plus 5, x minus 1, over now x plus 5 by factorising x minus 2. And we do simplify because this factor is common. So this becomes x minus 1 over x minus 2. We can't do anything more of that. Now we need to add all of this with 6. So then x minus 1 over x minus 2 add 6. Again, this is, remember, 6 is kind of like a fraction again. Any number can be a fraction. This is 6 over 1, okay? We can say this is 6 over 1. Then this becomes, then we need a common factor. So we're going to need x minus 1 over x minus 2. Then we need to add, we need a common factor. So we need to times x minus 2 to the top and bottom here. So it would be 6 of x minus 2 over x minus 2. So then we can add, so we can say x minus 1 and then add across because now they have the same denominator, just like with normal fractions. X minus 1 plus 6 lots of x minus 2 over x minus 2. And so then next expand the bracket, right? So then x minus 1 adds 6x minus 12 over x minus 2. And then let's simplify. So x plus 6x is 7x. And then minus 1 minus 12 is minus 13 over x minus 2. And this looks like this form here, doesn't it now? We're good. Because obviously if we then say, if we compare, A would be 7, B would be 13, C would be 1, and then D would be 2, okay? 7x minus 13 over x minus 2. Cool. And so that's the idea of this. Don't freak out because it looks a whole mess at the start. Try and break it down, right? You should know how to simplify or add algebraic fractions, right? Do it part by part. So this bit first. You can even simplify this bit if you want. You could factorize this bit first if that helped. But it wouldn't help really. Again, nothing would cancel at the start. But then if you do x plus 5 divided by this, you should then know the KFC to then get this fraction here. which you can simplify. Then you can add 6 afterwards. Don't try and think, oh God, there's so much going on. I can't do all this at once. Break it down, right? Forget about the 6. We add the 6 on at the very end. Let's do what's inside the bracket first. Like with triple brackets, you don't do them all at once somehow. You just do the first double bracket and then you times by the other bracket. Got the same sort of concept here. Okay, cool. Um, oh God, it's freezing now. I think if I do it for a while, if I'm on for a while, I think the laptop bugs out a little bit. Okay, we're heading towards the end of the paper now. Question 18. The vectors question. So we're given this quadrilateral. Obviously, that just means a four-sided shape. FE is A, ED is B, and CD is 2A. So they're given it all there. Now the totals of point P is such that CEP is a straight line and CE is equal to EP. So P is going to be about here, isn't it? Really? C to E is here, and then you're going to have E to P, about the same distance, right? That's what that's telling us. So B is going to be off the shape here. Then we need to prove that CF, which is this line here, has to be parallel to DP, which should be this line here. Okay. And they look parallel in a way. Obviously, not drawn the best way, but they kind of can be, right? But we need to prove it. And so the best way is actually, when it says use a vector method, you need to find vectors for CF and DP. So that's what we're going to do. So let's start with CF. So C to F, there is no direct vector here, but we can find another route. And that's the whole idea with vectors, is finding a different pathway, a different route to get to where we want. So from C to F, we can then say C to D, and then from D to E, and then E to F, and then we got to F right from C. Well, C to D we know is 2A, and D to E, well, E to D is B this side, so we flip. So if we go the other way, it's negative B. Okay. If we go the opposite way, we just add a minus. Okay. Then E to F, again, we're going backwards, so it's going to be minus A. So that's going to be 2A minus A minus B. So that's CF, that's great. Okay, now D to P. Okay. Now D to P, we don't really have a way of getting there because P's off the table. Not off the table, off the shape. But we are given that CEP is a straight line. So what that means actually, and you should remember this, is DP. Well, we're also given CE. CE is E to P. So D to P. How are we going to get from D to P? Well, we could say D to P is D to E. Add EP. Um. And so D to E. But again, it's going the other way, so it's going to be minus B. And then E to P. Well, we don't have an expression for E to P, but we know E to P is CE. That's what we're told. And we can work out how to get from C to E, can't we? So that's going to be minus B at C to E, which is C to F, and then F to E. And luckily, we worked out what CF is, which is here. So minus B add, and then CF is A minus B, and then F to E is A. Hang on, I should clarify that's minus B there. There we are. Cool. So then if we add it all together, so minus B minus another B is minus 2B. Hang on, let's put that here. Then A plus A is 2A. Okay, so now we found expressions for CF and DP. You should notice something now. CF is 2 lots of DP because A minus B is 2 lots of A minus B, right? No, sorry. Obviously that's not true. I don't want to say this. No, 2a minus b minus 2b. The other way around is 2 lots of a minus b. There we are. So obviously a minus b is cf, and 2a minus 2b is dp. So, no, sorry. dp is 2 lots of cf. There we are. So CF is A minus B, so DP is 2 lots of that, so 2A minus 2B. Hopefully you can see that right. Now, when two vectors are scalar multiples, so one's just a multiple of another, that means that DP is parallel to CF, as they are scalar multiples of each other. And that is your reasoning, okay? And that's all you need. Okay, what that actually means is that means they're the same direction. Okay, because if they are only differing by scale multiple, that's telling you that the distances will change. Like, the distance will change, but the direction doesn't. Okay, that's essentially what it means. So it does the same direction. It means the parallel, and that's what this method is bit ensures, right? If they're scalar multiples, like there are just two lots of each other, or half, or however you want to express it, then they have to be parallel. Okay, there we are. Cool. Okay, we are on question 19 now. I think there's 3 more questions. So we are given the graph with equation y is f of x. We need to sketch y is f of minus x. So what you need to know transformations like this is what if we change inside the function, that changes your x values, your x coordinates, because obviously that's your input, right? So your input is your x values, right? So if we're changing our input, so minus x instead of x, that will affect the x, okay? So minus x, well, what this is saying is almost f of minus 1 times x. So we're timesing each x coordinate, well, we're dividing technically. We're dividing up our x coordinates by minus 1, so the signs flip, okay? And that's what we can do. So we can just plot some points and take the negative or flip the sides, right? So this is minus 3 here. So this will shift to here, right, to positive 3. Here it's minus 1, this point here, so it'll go to 1. Okay. Here, well, 0, it will stay as 0. And here it's at minus 4, so it'll go to positive 4. So then obviously then if we connect our points here, 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 and here, it will, if we connect, it will look like, oh, that, right? And it looks a reflection, right? And that's it's a little bit off, actually. Let me correct that. Oh, God. Let me draw that a little bit more to make it more like a proper reflection. Hang on. God's sake. Yeah, my laptop's given up. There we are. There, oh, that looks even worse. There, something like that. Okay. So obviously, what this actually means, you could memorize it and realize this is a reflection in the y-axis. But if I don't memorize that because I just try some x values. I recognize you divided by minus 1. That's the same as just flipping the sign right of the x coordinates. So then I plot the x coordinates, the transformed x coordinates, a reflection, and then I connect it like this, and I'll spot it is a reflection in the y-axis. That's how you approach that, right? Should hopefully that made sense, right? Because that input here is just times it by minus 1, so minus x you just times it by minus. You know what I mean? You just times by the opposite sign. Okay, so that's 2 marks. Then we are given this. So we have a curve C here with this point on the curve, and it's transformed by a translation. That's going to be key to give the curve S here. So a translation, remember, is a vector. So x, y, it's telling you how many units it shifts to the left or right and up and down. So we're not stretching by a scale factor. We're just merely shifting it left or right or up and down. Well, here, if you notice, this point maps to here. we're not shifting it up and down. So actually, the 0 here is 0 for this part of the vector, translation vector, right? But it's moving to the right by 3 units. So it's going to be 3, 0. That's our translation vector, okay? So how to express that in the function? So f of x is our normal function equals c, our curve c. That's our f of x. We need to shift the function to 3 units to the right. That's going to be f of x minus 3. Because, obviously, like I said, you have to change the input to affect the x values, because it's the x values that are changing, right? If it's shifting left to right, that's affecting the x, obviously, because it's on the x-axis. But if it's shifting 3 to the right, we need to minus 3. Because what you do with these transformations, what you do to the x values inside the function, you do the opposite to what you expect. So if you're doing x minus 3 here, you'd expect to subtract 3. But instead, we're adding 3 to move it to the right. So you do the opposite. So if we're doing 3 units right, we're adding 3. We need to do the opposite, right? And we need to pull it as x minus 3. For example, another example, if you had f over 2x, for example, obviously you'd expect that you'd think it would double or times 2 every x coordinate. Well, actually, you're halving it. So you do the opposite to what you expect. If it's the y values, though, it does what you expect. So if we had 3f of x, you'd times 3 by the y coordinates, right? Anything outside f of x will affect the y. Hopefully that's clear. So that's what we need to do. So f of x is c, but our equation is 5 plus 2x minus x squared. Then we need to input x minus 3 in. So that's going to be 5 plus 2 lots of x minus 3 minus x squared. So it's minus x minus 3 squared. You might actually be okay with writing that in as your final answer, but I'm going to expand it. So I'm going to say 5 plus 2x minus 6 minus x squared plus 6x plus minus 9. That's what the expansion would give you. So then that would be minus x squared plus 8x. 6x and 2x is 8x, and then 5 minus 6 is minus 1, minus 9 is minus 10. And that is your equation for S. Okay, so hopefully that's clear what I've done there, right? So I've recognised this is when you translate it 3 units to the right. So, and if f of x is this and f of x minus 3 by substituting x minus 3 into the original equation here, will get us this, right? And then let's just expanded it. Okay. Okay, second to last question. We've got another ratio question. I have seen this come up from time to time, but I really do want to explain it. I think there's a good way of looking at this sort of thing. And it's going to be very similar to the other ratio question we did. So we are given this ratio. So we're given one ratio is equal to another. We need to solve for x. Okay. So I'm going to write this down again. 5 minus 3x to 9 minus x is equal to 3x plus 7 to 4 minus x. Okay, so when you are, so we need to get an equation for x, but it's, well, at least for me, at least, it's very, very, very tricky to spot what we need to equal, what these ratios exactly mean, especially when there's algebra in it. So what I'm going to do is, like I said before, I'm going to have to convert both ratios to the form 1 to n. And you'll see why. So how am I going to do that? Well, the first fact, I can just divide by the first number. So 5 minus 3x to both sides, that's going to be 1. Because 5 minus 3x divided by itself is 1. And then you're going to have 9 minus x over 5 minus 3x divided by 5 minus 3x. And then that's going to be equal to, I'm going to do the exact same to this. So now I'm going to divide both of these parts of the ratio by 3x plus 7. Then that would be 1, because obviously divided by itself, to 4 minus x over 3x plus 7. Are you okay? And now look, they're both in the form 1 to some number. What that means is if these two ratios are equal and they have the same number, that means these have to be the same. So 1 has to equal 1, clearly. But also, this second part has to be equal to. So 9 minus x over 5 minus 3x has to equal 4 minus x over x plus 7. So that is how you jump from here to get an equation we can solve for x. And then from now, we just multiply and then, do stuff from there. But that is the key idea with this sort of ratio question, right? Don't be thrown off. Try and just do this sort of thing. So make one number in common, and then you can equate and compare the ratios, as we've shown, right? And the best way is to divide by the first number on each of them, so they match, right? Okay. But then we can just solve it like a normal ratio, algebraic fraction, right? So if we times across, we can have 9 minus x, 3x plus 7. So we times it across there, and then the times across there, equals 4 minus x of 5 minus 3x. And then we're going to expand. So that's going to be 9 times 3x is 27x. Add 9 times 7, which is 63. And then minus x times 3x is minus 3x squared. And then again, minus x times 7 is minus 7x. And that's going to be equal to, then we expand the right-hand side. 4 times 5 is 20. 4 times minus 3x is minus 12x. Minus x times 5 is minus 5x. And minus x times minus 3x is plus 3x squared. Okay, I can simplify this things a little bit. So that I'll go to minus 3x squared. Add 27x minus 7x, that would be 20x, add 63. And so that will be 3x squared. Minus 5x minus 12x is minus 17x, add 20. So now I can spot this is going to be quadratic, so I'm going to rearrange everything to the right. So that will become, I'm going to write this up here actually. That will become 3x, if I add 3x squared to both sides, I'm going to get 6x squared. Then I'm going to subtract 20 to both sides, 20x. Minus 17x minus 20x is minus 37x. Then minus 63 to both sides, 20 minus 63 will be minus 43, and that will be equal to 0. Well, is that just not a quadratic we can solve? And I think probably the best way is perhaps, well, I think, is the quadratic formula, if you don't want to waste time on it anyway. So the quadratic formula, well, minus b, minus 37, plus 37, plus or minus the square root of b squared to minus 37 squared, minus 4 lots of a, which is 6, and c, which is minus 43, all over 2 times 6. And then you can just put that into the calculator, right? 6 minus 37. And so our solution is x is 43 over 6, or x is minus 1. Okay, cool. So the final question then, trying to keep the pace, and it's this. And these sort of like circle, radius, tangent questions are also pretty common. They're towards the end of the paper. It's like a grade 9 topic, but if you practice it, it's not too bad. So let's have a look. So we're given this circle with centre O, and AB here, this line is a tangent to the circle at A. OBA is 30, they're given that here. Point B is 16, 0, which is here, and P is 3P. We need to find P. Okay, for 4 marks. Okay. Well, immediately what you should recognise with these sort of questions is you're going to have to consider the radius, right? Because they told us it's a tangent and the point A is on the tangent. So we're going to need to consider the radius towards A. So 0 is our centre, remember? The centre O, our origin. So we need to consider the radius. But how should we? Well, we're given an angle. Which is interesting. I mean, this means it has to be a right angle triangle. because it's remember, a radius and the tangent is perpendicular to each other. That's the circle theorem. But we also know a side because this is now 16, is it not? And we get this triangle here. Oh God, what's this? We get this triangle here. Actually, let me make that a bit more clearer. Here, if this is O, and then that's A, that's a right angle triangle. And then B would that be 16 from O to B, right? That's a hypotenuse, because remember the right angle's facing the hypotenuse. What do we want? Okay, well, what we can find an angle. We know this is 30 as well. There we go. So we can use trig here, but what would we get? Well, this is the radius r, isn't it? So I think that might help, right? This is the radius r. I think we can find the length of r and see what happens. Well, I'm gonna need to remember SOHCAHTOA. Okay. So this is the angle, and the radius OA is opposite. So we need to consider the opposite and the hypotenuse. So it's going to be sine, right? Because we're dealing with a opposite and a hypotenuse. So sine of 30 is, and I write it in this particular order because then that's saying O is the top number, or R, over the hypotenuse of 16. Right, this is like, there's a lot of hidden fractions here. So sine 30 is the opposite over adjacent. Cool. Well, therefore, the radius of r is 16 sine 30 now. And you put that to the calculator, or you really should remember the exact value for 30, but luckily it's a calculator question, so you don't have to really in this case. But that'd be 8. Okay. So that's 8. Interesting. Well, that's just what I've done there was essentially use what I know. So what is so I know that the radius is also going to be perpendicular to the tangent. I know that. I'm used to that. So then I can construct the radius to be perpendicular. Then I'll spot we have a 30 degrees. So this looks like a triangle. And then I know a length of 16. So I can use some trig. And then I'm probably going to need the radius, right? Because this side isn't going to be useful, right? A to B, that's not of any use to me, but the radius could. So that's what I've done so far. I've worked that information out, might help me, and I might get some marks for it, you know. Cool. So the radius is 8, but would that then not mean that this is also the radius of 8? Because O to the another point on the circumference is also 8, the radius. Well, I can again. This would be a triangle, right? So O to P, and then to the x-axis. Well, the x value is 3p, and the y value is p. And we know the distance is 8. Can we not just then use Pythagoras to find the distance, right? The distance formula to find p. If I say Pythagoras, then if this is the hypotenuse of 8, 8 squared, a squared plus c, b squared is c squared, remember? So 8 squared would be 3p squared, add p squared. And then I can simplify that. 8 squared is 64. And then 3p all squared. Remember the third law, a to the m is n. What's going on here? A to the m is n. You times the powers, right? A to the mn. So 3 squared. So that's 3 squared p squared, which will be 9 p squared, right? Add p squared. So therefore 10p squared is 64. Now we've got an equation for p. Great. So then p squared is 64 over 10, which is 6.4. So therefore p is root 6.4. And then you put that into the calculator, you get this number here. Is there no more room? I'll do it here then. So p is root 6.4, which equals 2.5298, so on. And it's just a one decimal place, so it's going to be 2.521 dp. That's our value for p. Cool. So see what I've done there is I've worked out information that I can work out really without thinking. I know that I'm going to consider the radius probably because we've got a tangent. So then I consider the radius and I recognise that's the right angle. We have an angle. So I'm going to have a right angle triangle. So I'm going to use SOHCAHTOA probably. So then I found R. So the side, the information I might be able to work with. And then I could work with it because then I know that this side is also going to be the radius of 8. And then I'll just use Pythagoras. Cool. So that's it then. That's the paper. Well, not the paper. It's all the questions, right? It's like a paper, right? I've constructed the questions in a way it's sort of like a predictive paper. Okay, so what I'm going to do then is now I'm going to double check my answers. I'm going to leave it up, but hopefully it should be right. Um, but in this time as well, use if anyone is watching, ask a question. I've tried my best to answer it as well, whilst I check for the answer. Screenshot it and do whatever you want with it, with what I'm showing. But try and quickly check my answer so I can correct if I said anything wrong. Uh, 2.5, cool. Right, I remember this one. It was my. I'll double check it though. Yeah, -1 or 43/6. Cool. Okay. Uh, yeah, cool. But this one I don't really need to check because I've got the proof there. But I'll check it anyway. Guys, this is the awkward thing as well when compiling these papers at the end. When I check an answer, I have to go through so many different papers because obviously they're all from so many different papers. So constantly it's just a mess to try and crawl through it. Yep, DP is 2CF. Cool. Okay, question 17. I don't think that's the right paper. No, that's 2019. If anyone needs that question, it's from 2019. Yeah, that's right. 7x minus 13 of x minus 2. Cool. Question 16. Uh, 153.48, which is there. Yes, cool. Uh, 11.4 and 41.8. Cool. One. -2. Yeah, that's right. Yeah, cool. This one should be right as well because it literally showed you that. So I'm confident we'll answer there. Yeah, hopefully that made sense to people at the top when I went through it. The circle theorem one. Question 12. 2n squared minus 3. Cool. 6x cubed plus 35, x squared was 58 plus 21. Yep, cool. 6 desserts. Yep, lovely. Oh god, okay, this ratio. No, 2022, paper 3. 42 to 63 to 15 to 20. Yep, great. Question 8. So x is 6 here. I guess I'll highlight that. So that was 2017. Yeah, 6%, 5.99. Yeah, that's what we got. Cool. Question 7. Uh, yeah, that's fine. Yeah. Question 180 for the interquartile range. Yeah. Yeah, that's the box plot. Yeah, the median of the girls is higher than the males. Yeah, that's what I've got. Cool. Okay, good. I'm not selling anyone like false. I'm not giving false fake news. That's why I'm checking. So the density of 1.01, the overall at the end. So that's question 5, G27. 1.01. Yeah, cool. The error interval. 4.755 to 4.765. Yep. Make sure there's an equals to there. Because remember, that does still round up to 4.76, but that doesn't. So that is not an equal to, but that is. Okay, so the lower bound is equal to because it can round up, but that cannot round down. and the upper bound. Okay. God, hopefully I've not made any mistakes again. It's looking like it. That's cool. Venn diagram. 15, 5, 25. Yep, 7 over 5, 15. Cool. 0.319. Yep, great. And then we're here at the start again. So I check this one. But like I said, I'll be around for like 30 more seconds or so if there are any comments. But after that, I'm going to head off, put this onto YouTube, and as soon as possible, then export that, and then everyone can see it and access it the live whenever they need to. And yeah, that's all fine. Okay, cool. I didn't make any errors, which is quite a surprise for me. No silly mistakes. Cool. So yeah, that's the questions. I don't see any questions from the chat, so I'm gonna leave that there. Then I'm gonna end the stream there. I'm gonna put this onto YouTube then, so everyone can access it whenever. I don't know, for me, I find YouTube as well. It's a lot easier to watch videos and record or pause or access it over time, stuff like that. But yeah, I'm gonna leave it there then.